Hi guys, today we're going to take a look at question 5 of paper 1 of the 2016 exam. Okay, so the lengths of the sides of a right angled triangle are given by the expressions x minus 1, 4x, and 5x minus 9 as shown in the diagram. And we want to find the value of x. Okay, well, we have a right angle triangle, so straight away, first thing, before I even read the rest of the question, Pythagoras' theorem, a squared plus b squared equals c squared, where c is the length of the hypotenuse. And the hypotenuse is the side opposite the right angle. So it's this side here in this question. Length of the hypotenuse. Okay, so we know that the lengths of this are x minus 1, so we can let a equal x minus 1. B is 4x, the other length. And c, the length of the hypotenuse, is 5x minus 9. And now we can just kind of sub these in to our Pythagoras' theorem equation, and we'll get an equation in x. So if we just sub this in, we'll get x minus 1 squared plus 4x squared equals 5x minus 9 squared. Okay, so let's just square these terms, and we get x squared minus 2x plus 1 plus 16x squared equals 25x squared minus 90x plus 81. Okay, and you can kind of see we're going to get a quadratic equation of sorts here. Okay, so if you bring everything over to the right hand side, then we're going to get 25x squared. So let's write the x squared terms first. Minus x squared minus 16x squared. Now let's write the x terms then. So minus 90x plus 2x, and then the constants, plus 81 minus 1. So this will equal 0. Okay, so this gives us 8x squared minus 88x plus 80 equals 0. And now you could solve it like this, that's perfectly fine, but you might notice that there's a common factor of 8 here, so we can just divide across by 8 just to make it a little bit easier. X squared minus 11x plus 10 equals 0. And now we've got a quadratic equation straight away, minus b formula. X equals minus b plus minus the square root of b squared minus 4ac all over 2a, where a equals 1, b equals minus 11, and c equals 10. And then if we sub this in, we see that x equals 10 or x equals 1. Okay, well, let's go back up to our triangle. So if x equals 10, well then the sides are 9, 4 by 10, 40, and 50 minus 9, 41. Okay, seems pretty reasonable. And if x equals 1, well then, wait a minute, this length is 0, this length is 4, and this length is minus 4. Well, that doesn't make any sense. Okay, so we're going to ignore this answer because this can't be right. I mean, it works out in the equation, but it doesn't actually make sense as an answer. So our answer is just x equals 10. And if you wrote both of these answers, you'd still get most of the marks, but you wouldn't get the full marks. So just this careful kind of little details at the end are good to be aware of. Now, on to part 2. Verify with this value of x that the lengths of the sides of the triangle above form a Pythagorean triple. Well, what the hell is a Pythagorean triple? Well, straight away we've got a weird term, Pythagorean triple. So let's define that, and that might make the question easier and give us some points straight away. Well, a Pythagorean triple is a 3 natural numbers that satisfy Pythagoras' theorem. So, for example, the classic Pythagorean triple is 3, 4, and 5, because 3 squared plus 4 squared is 5 squared. Okay, well, 9, so the length of one is 9, so 9 squared plus 40 squared, the length of the other, does that equal 41 squared? Well, of course it does. That's how we found it out. So, yes, 9, 40, 41 forms a Pythagorean triple. Now, you might, well, that's so obvious that it, and it is, because that's basically how we did question 1. And this question is more testing, do you know what a Pythagorean triple is? That's basically what the question is. They're not really asking, does it form a Pythagorean triple? Because it obviously does if you know what a Pythagorean triple is. And that's really what they're asking here. Now on to part B. Show that f of x, which is 3x minus 2, where x is real, is an injective function. Alright, so straight away, we've got a term here. What does injective mean? Injective, well, an injective function is, injective means that if f of x equals f of y, then x equals y. So it's basically saying that it doesn't send two different points to the same point. So something that wouldn't be injective would be a quadratic, let's say. So let's say we have a quadratic, something like this. Okay, well, if you draw a horizontal line, it actually hits the same point. It hits the line twice. So with an injective function, a horizontal line only hits the graph once. Always. Okay, and so, well, how would we test for that? Well, there's a few ways that you could do it. You could use, so the easiest way to do it, well, let's just suppose that f of one value equals f of another value. f of x1 equals f of x2. Well, what is f of x1? Well, f of x1 is by our function. Well, what is our function? Let's just quickly write that down, get ourselves some marks on the board. So f of x1 will be 3 times x1 minus 2. And f of x2 will just be 3 by x. Now on to part B, we want to show that f of x equals 3x minus 2, where x is real, is an injective function. Okay, so straight away, let's get our function down. F of x equals 3x minus 2. And now, well, what is an injective function? An injective means that it doesn't send any different points, doesn't send any different points to the same point. So if the input is different, then the output will be different. So this is sometimes known as one-to-one. And in maths terms, you can write this as if f of one value, x1, equals f of a different value, x2, then the two values are the same. That's what it looks like in maths terms. Okay, well, how would we show that it's injective? Well, let's let fx1 equal x2. Let's let f of x1 equals f of x2 and see what happens. Well, what is f of x1? Well, f of x1 is just 3 times x1 minus 2. And f of x2 is 3 times x2 minus 2. Okay. Well, now the 2's cancel, so we get 3 times x1 equals 3 times x2. Okay. And then if we divide by 3, we show that x1 equals x2. So we let f of x1 equals f of x2, and then we got that x1 equals x2. So this is satisfied. So we get this thing here. If f of x1 is f of x2, which we allowed, and then you get that x1 equals x2, which is what we got here. And then so f of x is injective. And it's just as simple as that. Now on to part 2. Given that f of x equals 3x minus 2, find a formula for f inverse, the inverse function of f. Well, what is the inverse function? The inverse function. Well, that would be a function which we call f inverse. Well, it's an f inverse such that if we did f inverse of f of x, then we just get x. So it's basically, it's f but backwards. So if f goes from here to here, then f inverse goes from here to here. So it goes backwards. So f inverse of f of x would be like going all the way over here and then going back. So you just end up where you started. So f inverse of f of x is x. All right, okay, so, well, how does that help us find what f inverse is? Well, we have a formula to find f inverse. And it goes like this. So you start off with f of x. You start with f of x. And we're just going to let f of x equal y. Okay. And then we want to find we want to express x in terms of y. So express x in terms of y. Okay. Well, let's do that. So f of x, or y, equals 3x minus 2. Okay, and now we want to express x in terms of y. Well, if we we want to isolate x, so y plus 2 equals 3x. So x equals y plus 2 all over 3. And then the next part of the formula is you kind of like replace y with x, and then let f inverse be the function. So let f inverse of x equal, well, in this case, it would be y plus 2 over 3, or not y, x plus 2 over 3. And now this might seem like a bit of a weird formula, but let's just try it out. Let's just try it out, just see if it works. So f inverse of f of x, well, f of x is, so that would be f inverse of 3x minus 2. So wherever we see x, we're going to sub in 3x minus 2 into f inverse of x. So 3x minus 2 plus 2 over 3. Okay, well, the minus 2 and the 2 are going to cancel, and we're going to get 3x over 3, and then the 3's are going to cancel, and we're just going to get x. So f inverse of f of x is just x, which is, as we pointed out here, that's the definition of f inverse. So we know that we've gotten f inverse right. And the reason that this formula works is because you're kind of looking at, well, what are the steps that we would need to take to turn f of x into x? And those steps in this case are by adding 2 and then dividing by 3. And so we have our formula f inverse of x equals x plus 2 over 3.